So the first two classes, whatever we had so far, we had talked about the basics of chemistry. Okay, what are elements, what are atoms, how do they combine to form molecules, and when they form from atoms, they become molecules. There are two different ways in which they can do. One is ionic bonding, one is covalent bonding. We talked about that in the previous class, right? Two types of bonding we talked about. Go ahead, tell me. Say that again. I couldn't hear you. Yeah, sure. Okay. So ionic bonding, you remember? So ionic bonding, like I said, ionic bonds are formed by loss or gain of electrons. One atom will lose electrons, other one will gain electrons. Like example, this is ionic I'm talking about. Ionic bond. NaCl is an example of ionic bond. And Na becomes positive and chlorine becomes negative. But in case of covalent bond, the electrons are not given or taken away, but they're shared by both the atoms. So we can take the example of hydrogen gas, like I said, H2. This is a molecule. It is formed with the help of two atoms. H2 means what? It has two atoms of hydrogen. One H, another H here. Let's say this is the nucleus. And around the nucleus, you will have, of course, electrons. So since it is hydrogen, it has only K shell, only one shell, which has one electron. And you know that for the first shell, that is K shell, the maximum number of electrons it can take is 2. So 2 is the number which will make it stable. So what happens? They form a covalent bond, and they share this electron together. So now both the electrons belong to both the hydrogen atoms. They will be close together. The hydrogen nucleus will be close together, and the electrons will be shared by both of them. Okay. And the covalent bond, that is represented by a single line like this, H and H. Another example will be oxygen, O2. For oxygen also, there are two oxygen molecules, and both oxygen molecules make covalent bonds with each other. So this is the nucleus. Around the nucleus, what is the electronic configuration of oxygen? Confirm. Tell me, all of you. You should be able to tell me electronic configuration. 2,6. Very good. Electronic configuration of oxygen is 2,6. So in the first shell, there is going to be 2, and the last shell going to be 6. So I'm going to skip the first one. I'm going to draw only the outermost shell, because that's the one which takes part in reaction. Remember, okay? So the inner shells, they are not that, I mean, of course they're important, but they don't take part in chemical reactions or bond formation. They don't take part in them. So I'm just drawing the outermost shell, and it should have how many? 6 electrons. 4, and then 5, 6. Also here, 1, 4. So what happens? Two electrons, they share with each other. They share 2 electrons with each other. Hydrogen was sharing how many electrons? Each one was sharing one electron. But in case of oxygen, both of them are sharing 2 electrons each. You should be able to understand why they are sharing 2, right? Because the outermost shell right now has how many? 6 electrons. and how many more it needs to make the octet, to make 8 electrons in the outermost shell. That is why it takes 2 from the other oxygen. And since they're sharing, so now the 6 from the original 6, this first oxygen, they already had 6. They have shared 2 more from the other guy. So now it becomes 8. Same thing for this one also. Already had 6. This also becomes 8 now. Okay. So since 2 electrons are shared like this, so this kind of bond, when it is formed, you write it two lines like this, and it's called a double bond. Okay. So you will learn about single bonds, double bonds. We will talk about that later when we start the carbon chapter. Okay. So for now, just high level idea: ionic bond, and yeah. So is that clear? Covalent bond. So we went from atom to molecules, but you know that the chapter which we are going to study is chemical reactions and equations. So the chemical reactions, when they take place between different molecules. Different molecules combine together or disintegrate. Sometimes one big molecule may disintegrate to become smaller, two smaller uh, molecules. So these molecules take part in chemical reactions. So which is what we are going to start now. We are going to talk what it means to be saying that there is a chemical reaction taking place. Yeah. Start with chemical reactions. So if you people want, you can keep on writing when you have time, but don't write your notes at the cost of losing what I'm saying. I mean, when I say something, keep your focus on that. Meanwhile, if you can copy, if you copy very fast, you're okay with that, then you can do it. Your wish. But I'm going to share this thing anyway in the class, after the class. Okay. So what does it mean to say that the chemical reaction has taken place? Anybody knows anything? You have studied about chemical changes and physical changes in your earlier classes, right? When do you say that a chemical change has taken place? Anybody remembers? Yes, very good. Process cannot be reversed. Excellent. Any other points you remember? What happens when a chemical change takes place? Very good. New products are. And anything about the properties of new properties? New product, when we say they have new products with different properties compared to the original one. Chemical reaction. No, see, I think you are talking about atoms. Are you talking about in a chemical reactions, atoms are not created, neither destroyed? That is true. In a chemical reactions, no atoms, neither atoms are created nor destroyed. What is the spelling of neither? Created nor destroyed. So what happens in that case then? Atoms are not created. They just change their bonds. The bonds are formed between different atoms and molecules. So we'll take examples of that. Anything else? Anybody remembers? Yes, the number of atoms. Yeah, actually that has to do with the same point. But of course we can say that the number of atoms will not change after the reaction or chemical reaction has taken place. That is what it means to say that atoms are neither created nor destroyed. So whatever atoms were there before, they are not destroyed means they will be there after the reaction also. Right. Fine. So let's try to write a simple definition. What would you have to write when they say that write a definition of a chemical reaction? So you should say that it's a process Okay, so in a process, it is a process in which old chemical bonds are broken and new bonds are formed. And the products thus formed have different properties. So after the chemical reaction, whatever new products you have got, they will have different properties compared to the reactants. Okay. So okay, let's talk about some examples. Give me some examples of chemical changes. Very good. Burning of a piece of paper. So before earlier it will be white, it will burn and it will become ash, right? So ash is totally different properties compared to the paper. Anything else? Lots of examples around you. Think about it. Yes, cooking of food. Anything else? Yeah, growing up, of course. But chemical change, don't use that example. Think about where something is there and immediately it changes to something else. Okay. Growing up, it's not an immediate change, right? It happens gradually over time. So cooking of food, and when you eat the food, what happens? The food gets digested, right? When you breathe in water vapor, what about that? Change of water from liquid to water vapor. That's what you mean when you boil water. Yes, of course, that is an example. They have different properties. What is the difference between them? Earlier it was liquid, later it becomes gas. So change of state, that is also an example of chemical reaction, chemical change. Oh, but that is a physical change, right? No, no. See, chemical changes, chemical reactions. Evolution of a gas. No, it's not. Change of state is there, but water when you heat it and it becomes gas, it is not a chemical reaction. Okay, there's no chemical reaction taking place. Okay, I will confirm about that. Physical changes, since I don't teach science to ninth standard, that is something in the ninth standard you had studied. So I don't see that too often. So I'll just check that example whether it's valid for a chemical. It's not a, see, something that can be reversed back to the original state. You should not call that as a chemical reaction, right? So if a wax melts, you can always freeze it back again to the solid state. When you have gas, you can condense it down back to the liquid again, no? Just by making some physical changes. But I'll confirm that, okay? Whether that will not be a part of chemical reaction, but I'll confirm that in the next class anyway. Okay. So let's take some examples which are very easy to understand, like cooking of food. When you cook the food, it is in a different state, and there are some chemical changes happening when you cook because you put up a lot of heat over there and a lot of other ingredients you put. So some changes happen, and you cannot reverse it back to the original state once cooked. Then digestion of food in the body, respiration. When we breathe in oxygen, that oxygen gets into the blood and that is used up, and then carbon dioxide is released outside, right? So that is also a chemical reaction. So these are all the simple examples which we see around us. But to take up some examples like which you would be studying in reality in this science book, let's say burning of magnesium ribbon. This is also an example of chemical reaction. And to add a few things, like you can say rusting of iron. Okay. Right. Let's go to the NCRT book so that we don't miss anything. Can everyone see the book? Okay. So we have talked about all this. We will be reading this activity. All of you read this activity on your own, and then we'll talk about it. Read it right now, very quickly. Go through it. And I want you, one of you, to read this aloud for me. Who will read? Who's a volunteer? First volunteer. Yes, Nitya, go ahead. So in this activity, what are they asking us to do? Everyone has read it? Okay. So they're asking us to take this magnesium ribbon. Now this magnesium ribbon is nothing but simply magnesium, that's all. Chemically, it is just magnesium. It is in the form of a ribbon. And then they're asking you to rub it with sandpaper to clean it. Why are they asking you to do that? There is a reason for that, because we are trying to test some chemical reaction, whether reaction is taking place or not. So when you keep something outside, you know that rusting takes place, right? It will be exposed to air outside, and some amount of rusting takes place. So as of now, you would be knowing rusting in iron only, okay? But this same thing happens with other metals also. Rusting has different names, but it happens with other metals also. Magnesium is also a metal. So when you expose it to air, it will react with the oxygen in air, and it will make some coating outside, and it will be a magnesium oxide coating. And you want to clean it up before doing this experiment. So that is why they are asking you to clean the magnesium ribbon with by rubbing it with a sandpaper. Do you know what a sandpaper is? It's a very rough paper which is used for rubbing something to scratch it or to remove rough surfaces. Okay. Yeah. So we have done the cleaning, very fine. We have got some magnesium ribbon, and we know that it's just pure magnesium. That's all. And then what do? They're asking us to hold it with a pair of tongs. What is a tong? This kind of scissor kind of thing, what is there over here? That's what is called a tong. So when you go to your school, and if you get a chance, you will be able to see this way. Okay. They're asking you to hold it with a tong, keep it away from you, and then try to burn it on a burner. So what really happens is, when you do this, it will burn with a very bright light. A very bright white light will be emitted, and it will burn rigorously. So in terms of chemistry, it's called burns with a dazzling white light or something. Let's see what it says. Yeah, so you must observe that the magnesium ribbon burns with a dazzling white flame and changes into white powder. So if you have a book with you, underline this part from here to here. It's important. And not only that part, this one also. This powder is magnesium oxide. Up to here. So this is related to your activity 1.1. Okay. Now let's see what happens in this activity, or the burning of magnesium ribbon, chemically. So when you say magnesium ribbon, it is actually magnesium. So this is activity 1.1 of chapter 1. And when you burn it in presence of oxygen, The reaction which takes place by burning is it is with oxygen only. So actually magnesium is reacting with oxygen in presence of heat. And what is formed? Magnesium oxide is formed. And this is the white dust, what you would see. Which the words they have used over here is white powder. So you need to keep, whenever you read the NCERT book, make note of all these wordings also, because they will ask you questions like, you take some compound and you burn it in presence of oxygen and some white powder is formed. They will not tell you that it's a magnesium ribbon or you are doing some activity. They'll just tell you there is a compound X, you heat it or you burn it, and there will be a white powder formed. So just by knowing this white powder, you should figure out that they are talking about this particular activity. Okay, this white powder is nothing but magnesium oxide. So these wordings are important. Don't take it lightly. So what is that white powder now? Everyone is clear with that? It's magnesium oxide. Now I have written this reaction just in terms of words. I have not written their symbol MgO2 or MgO. Those things we will see once we learn how to balance equations. Okay. So let's just leave it at that as of now. Everyone is clear with this activity 1.1? What are the important points to note? Important points to note here would be, I will write it down for you and you can make a note of this, that burns with a dazzling white flame, magnesium ribbon, dazzling means what? Very bright, okay? And that is the reason they ask you to wear some eye protection. Can you understand the reason for that? Why they ask you to wear eye protection? Because it burns with a very bright light, dazzling light. So it will damage your eyes if you don't wear some protective gear or something. And if you keep it very close to your eyes and then try to burn it. Dazzling white flame. Important point to remember. Next point was magnesium, a white powder is formed. And this powder is actually magnesium oxide. Okay. And then also one small point to remember is, why do we clean that? So magnesium ribbon is cleaned by rubbing with sandpaper. Why is it done? No, it's not for preventing rusting. Don't confuse with that. It has already rusted, because if you keep some, if you buy magnesium ribbon from the shop, it will be kept open most probably, or at least while you have taken it out from the box wherever it was preserved. If you keep it open in air for some time also, immediately it will react with some oxygen. No? It will not immediately, but it reacts with oxygen. Magnesium is a very reactive metal. You will learn that in later classes. So it forms oxygen. So it has already rusted. Why are we rubbing it with sandpaper? We want to clean that coating. And what is that coating basically? That is also magnesium oxide, because it was already exposed to oxygen. So there was a thin coating of magnesium oxide again. That is what we are trying to rub it off by cleaning with sandpaper. So confirm all of you. Are you clear? Why do we rub it with? Why do we clean it by rubbing with sandpaper? So right, this is done to remove the protective layer of magnesium oxide. So once the outer layer reacts with magnesium and it makes a small thin coat of magnesium oxide, it will stop the rusting further. No, the inner layers of the magnesium will not react with oxygen anymore, and that's the reason they are calling it as protective layer. Okay, don't get confused by that. Why are they calling protective layer? Because once thin layer is formed outside, it will not rust the inner layers. That is why this is a protective layer. And what is this? This is also magnesium oxide. And in the reaction which we did when we heated, there also this magnesium oxide is formed. But here it's a very thin layer. That's why you do not see white powder over there. Okay, it's a very thin layer. But if you rub it with sandpaper, you see it will expose the original magnesium. Fine. So confirm all of you. Activity 1.1 should be totally thorough with it. Now, before we end today's class in 5 minutes, we only have that much time left. Very quickly, we will discuss some characteristics of chemical reaction. So we first understood what is chemical reactions. We took some examples of chemical reactions, and I explained you one of the chemical reactions in full detail, which was activity 1.1 actually. Okay, this is one of the chemical reactions which we learned in little bit detail. Now we are going to the next part. We are trying to understand what are the characteristics of chemical reaction. If you get to write this question for your answer in your exam, what will you have to write? What are the characteristics? How do you know that a chemical reaction has taken place? What are the characteristics? All those words you should understand. So in simple words, the characteristics would be, if you see an evolution of gas, some gas should be evolved. That will tell you that some chemical reaction has taken place. Formation of some precipitate, some kind of precipitate. Do you people know what a precipitate is? Have you ever heard of a precipitate? Yes, you're on the right path. Inside a liquid, when you try to mix something which does not dissolve completely, so it remains as a precipitate, right? Something which is insoluble in liquid, that forms as a precipitate. So when you're doing some reaction, if you see that some precipitate is formed, you can understand that. through more details of all these things, but just on a high level, understand formation of evolution of gas, formation of precipitate, change in color. Then anything else? Do you people know? Change in temperature or change in state. So I think evolution of gas means some gas will be evolved. Precipitate, I told you what it means. Color, everybody should understand. You're doing some reaction. Earlier it will be in some color. After reaction, the color will change. So that will also indicate that chemical reaction has taken place. So change in temperature. Either something gets very hot or it cools down. That is also an indication that some chemical reaction has taken place. Change in temperature. Now, change in state. What does it mean? Going from Tamil Nadu to Karnataka? Yes. So change in state. Originally, it will be in one state. After some reaction, liquid may change to gas or something else. Okay. That will also indicate that. Okay. Right. So that's all for today. In the next class, what we will do, we'll go through these points and maybe we'll take some examples of each of them and try to understand this in more detail. Okay. How this indicates that a chemical reaction has taken place. So anybody has any questions from today's class? No, they may all, it's not like everything will be there in all the chemical reactions. And it's not like if one of them happens means you can be sure that it's a chemical reaction. These are all indicators. This tells you, okay? So in some chemical reactions, a combination of one or two or maybe three will happen. All of them may be happening in the same time also in some chemical reactions. That is also possible. Okay. Anything else? Any other questions? Yes, tell me. Ritesh, you asked me first. Go ahead. No, I couldn't hear you. Say that again. Repeat your question again. Burning and combustion. Is there a difference? Anyone has any idea about this? See, burning is just a simple English term. Combustion is scientific way of saying that burning is taking place. Now it can happen in presence of oxygen, in absence of oxygen, both ways, but still it will be called combustion only. Okay. Yeah. So scientifically, there is, you should not think about the difference between them. Burning is just a simple common language term. Combustion is the scientific term for burning. Anything else? Yeah, someone else was asking. Who was that? Yeah, go ahead, tell me. can think of temperature changed, color changed. Precipitate was not there because there was no liquid over there. Solid magnesium ribbon was also solid, and we were just burning it, and it became ash, right? It got converted to magnesium oxide. Okay, so color was changed. Initially, it would have had some different color and became white powder. And then state was also same, earlier also solid, now also solid. So state did not change, but of course, temperature would have changed. Yeah, there was no gas was evolved over here. Okay, gas evolution was not there in that particular reaction. We will take some example. Yeah. Yes, tell me. Go ahead. Go ahead. Okay, so that's the reason I did not write that, because right now you have not learned balancing of equations, right? That's why I did not write it. But since you have asked me, let me just show you quickly. Okay. So Mg and O2, you will have MgO. Okay. Now you have to balance this equation. So how does that happen? You will have to take 2 molecules of magnesium and you will get 2 molecules of MgO like this. Now it became balanced. So nothing has been destroyed, nothing has been created new. So there were 2 molecules of this, Mg, Mg, and 2 atoms of magnesium before. There were 2 atoms of oxygen. So these 2 combined and these 2 combined, that's why you have 2 molecules of MgO. Does it make sense? Okay, so we will learn about this in more detail, how to do balancing of these equations. Probably in the next class, if we are able to finish this quickly. If not next class, maybe the class after that. Okay. Yeah. Anything else? Any other questions? Fine. So looks like nobody has any other questions. Now we can stop the class. But before you go, let me just tell you one more thing. Saturday. Every Saturday, like I told you, that it will be reserved for some purpose, for revision, for asking doubts from the whole week, whatever you had studied. Maybe we did not have time or whatever, or you did not go through at that time. But by Saturday, make sure that all of you go through all the recordings again and you prepare your notes, understand everything. Whatever you don't understand, have that. Like, you can keep asking me doubts in every class also, but if you miss something, make sure that by Saturday you get it clarified. On Sunday, you should not have any doubt from the previous class, previous week. Okay. Yes, tell me. Yes, we will have test whenever we have covered some portion which which can be tested. Then of course I will take a test for that, and tests will be on Saturdays only. Yes, tests will be on Saturdays only. Yes, tell me. No. Whatever is left behind, that you don't call it as a precipitate. Precipitate is a specific term. It has to do with some liquid. Inside that liquid, if you have some particles which do not get dissolved in that. Okay. So we will take some examples of this also in the next class, and that time I'll explain this in more detail. Okay. But it's not just the residue. Okay. The residue is called a product. Reactants and products. In a chemical reaction, like you take this example itself. So these 2 are the reactants. Okay, reactants. And this is your product. Now, product could be anything. It could be ash, it could be liquid, solid, gas, anything it could be. So not everything will be called as a precipitate. Precipitate is specific to liquid. Inside a liquid, when something is not dissolved completely, that forms a precipitate. Anything else, anyone? No, you can ask me as many questions. Don't worry about the time. Keep on asking me. Go ahead. Okay. See, liquids will be formed, but normally it's not like something is solid and then you get a liquid out of it. That rarely happens. Normally liquids are formed from other liquids, normally. But it can happen, of course, that is true. Like gases are evolved, we can have some solids reacting with each other, which may become liquid. But from solid to liquid, that rarely happens. Most of the reactions you will see some liquid will be there that will get converted into some other liquid or gases. That's more often, that's what happens. But it's possible. Anything else? Any other questions? No? Okay, fine then. That's it for today. I'll see you people tomorrow then. Bye. See you all. See you. Bye.